Dear cadets, a very good morning to you all. Hope you all are fine at your home. Due to corona pandemic, our regular classes are not taking place. So now I am here to take your class virtually. I welcome all of you in my class and the topic is HCF and LCM of algebraic expressions from chapter 4.4 of your book. Learning outcome. After the class, the cadets will be able to rules of finding HCF, rules of finding LCM, determine HCF of the expressions, determine LCM of the expressions. Now we discuss about HCF. HCF, HCF means highest common factor. The largest or greatest factor common to any two or more given natural numbers is termed as HCF of given numbers. HCF is also known as GCD, that means greatest common divisor. For example, HCF of 4, 6, and 8 is. Here we divide 4, then we can write 2 into 2. 6 is equal to 3 into 2. 8 is equal to 4 into 2. Here we can see the highest common factor of 4, 6, 8 is 2. Common factor. The expression which is a factor of each of two or more expressions is called common factor. Example, x is a common factor of the expressions xy, x square y, 5x. Here x is common all the terms. In algebraic expression, the definition of HCF. The product of common factors of two or more expressions is called the highest common factor, or in brief HCF, of those two or more expressions. Example, the HCF of three expressions x plus y whole square, x plus y whole cube, x square minus y square is x plus y. Here we can write x plus y whole square is equal to x plus y into x plus y. X plus y whole cube is equal to, we can write x plus y into x plus y into x plus y. And x square minus y square is equal to, we can write a x plus y into x minus y. And all these three terms, x plus y, are common. That's why the HCF is x plus y. Lowest common multiple, or LCM. The least or smallest common multiple of any two or more given natural numbers are termed as LCM. For examples, LCM of 10, 15, and 20 is 60. In algebraic expression, the lowest common multiple, or LCM, among different multiples of two or more expressions, the common multiple which consists of lowest number of factors is called least common multiple, or LCM in short. Example, the LCM of three expressions x plus y whole square, x plus y, x square minus y square is x minus y and into x plus y whole square. Here we can see x plus y whole square is equal to, we can write x plus y into x plus y. X square minus y square is equal to, we can write x plus y into x minus y. Here x plus y into x plus y are common. That's why you can write x plus y whole square and x minus y. That means the LCM of this given expression is x minus y into x plus y whole square. How to find LCM and HCF? We can find HCF and LCM of given natural numbers by two methods, that is prime factorization method and division method. In prime factorization method, the given numbers are written as the product of prime factors, while the division method, the given numbers are divided by the least common factor and the continuous still remainder is 0. Note: prime numbers are numbers which have only two factors, that is 1 and the number itself. HCF by prime factorization method. Given natural numbers are written as the product of prime factors. To be obtained, the highest common factors multiply all the common prime factors with the lowest degree. Find HCF of 20 and 12 by prime factorization method. Step 1. To find HCF of 20 and 12, write each number as a product of prime factors. Then 20 is equal to 2 into 2 into 5. That means we can write 2 square into 5. 12 is equal to 2 into 2 into 3. That means we can write 2 square into 3. Step 2. Multiply all the common prime factors with the lowest degree. Here we have only 2 as a common prime factors with the lowest power 2. That's why we can write HCF of 20 and 12 is equal to 2 square is equal to 4. LCM by prime factorization method. Here given natural numbers are written as the product of prime factors. The lowest common multiple will be the product of the all prime factors with the highest degree. Find LCM of 20 and 12 by prime factorization method. Then solution. Step 1. To find LCM of 20 and 12, write each number as a product of prime factors. Then we can write 20 is equal to 2 into 2 into 5. That means 2 square into 5. 12 is equal to 2 into 2 into 3. That means 2 square into 3. Step 2. Multiply all the prime factors with the highest degree. Here we have 2 with the highest power of 2. Here 2 is the highest power of 2 and the prime factors are 3 and 5. Then multiply all this, we get LCM. Then the required LCM is 2 square into 3 into 5. That means 60. Now we discuss HCF and LCM of 420 and 132 in another way. We can find HCF and LCM with the help of Venn diagram. Firstly, we divide the given numbers as a product of prime factors. Now putting the numbers in Venn diagram. Here, this is the product of prime factors, and putting these numbers in Venn diagram. Here we can see the common term is, this is So HCF is equal to 2 into 2 into 3. That means 12. And the LCM 5 into 7 into 2 into 2 into 3 into 11. That means 4620. HCF and LCM relation. The product of LCM and HCF of the given natural numbers is equivalent to the product of the given numbers. The LCM of given co-prime numbers is equal to the product of the number since the HCF of co-prime number is 1. Now, rules of finding HCF and LCM of fractions. LCM of fractions is equal to LCM of numerators divide LCM of denominators. HCF of fractions is equal to HCF of numerators divide LCM of denominators. Find the HCF of these expressions. Firstly, we divide the given number as a product of prime factors. Then we have to be found a prime factors of those algebraic expressions. Here first quantity 20 x cube y square a cube b4. Then we can write the common prime factors 2 into 2 into 5 x cube is equal to x square into x into y square into a cube into b square into b square. The second quantity 15x4 y cube a4 a to the power 4 b cube. That means we can write 3 into 5. 15 is equal to 3 into 5. x4 is equal to x square into x square. Y cube is equal to y square into y. A4 is equal to a cube into a. B cube is equal to b square into b. And the third quantity 35 x square y4 a cube b square is equal to, we can write 35 is equal to 5 into 7 and the prime factors, and x square y4 is equal to y square into y square a cube and b square. Here we observe that the 5 is common, all the terms, all these expressions. Here the common factors of the expressions are x, y, a, b, and the highest common power among these expressions is x square, y square, a cube, b square. That's why the required HCF is 5 x square, y square, a cube, b square. Now another type of problems. Find the HCF of the expressions a square minus 12a plus 35 and a square minus 8a plus 7 by factorization. Solution. First expression a square minus 12a plus 35. Now we use middle term factors or middle term method. Then we can write 35 into 1 is equal to 35 divides 35. Then we can write 7 into 5 minus 7a minus 5a is equal to minus 12a. Now common a, then we can write a minus 7, minus 5 common, then we can write a minus 7. Here a minus 7 and a minus 7 are common term, and a minus 5. Now the second expression, a square minus 8a plus 7. Now we'll term this term, a square minus 7a minus a plus 7. Now a common term, a minus 7 minus 1 common, a minus 7. Here a minus 7 is common term and a minus 1. Here we can see a minus 7 and a minus 7 are common term of these two expressions. Now the required HCF is a minus 7. Find the HCF of the expressions. Solution. The first expressions, a square b into a cube minus b cube. At first, we have to be found the prime factors of those algebraic expressions. Now we can write a into b. Here we can see a cube minus b cube is equal to, we can write a minus b into a square plus ab plus b square. Now the second expression, a square b square into a to the power 4 plus a square b square plus b to the power 4. Now we will try to formulate these expressions. Then we can write a square b square is equal to a square to the power whole square plus 2a square b square plus b square to the power whole square. Here we can see a square b square are more here. That's why we subtract a square minus b square. Then we observe that a square b square into a plus b whole square. That means a square plus b square to the power whole square minus a square b square. Here we can see this is another formula. A square minus b square is equal to a plus b into a minus b. Then we write a into a into b into a square plus b, a square minus b square is equal to a plus b into a minus b. Now the third expressions, here we can see the common term is a b square. Then we can write a square plus ab plus b square. Here we can see the three expressions, a square plus ab plus b square are the common terms of these three expressions. Also, we see ab are the common terms. That's why the required HCF is ab into a square plus ab plus b square. Now find the LCM of the expressions. At first, the LCM of the given expression of the numerical coefficients have to be determined. Here the numerical coefficients means 3, 4, 5, 12. The first quantity, 3x cube y square. The second quantity, 4xy cube. Third quantity, 5x4 y square z square. And 12xy4 z square. Now we find the LCM of 3, 4, 5, and 12 is 60. and the highest power of x is x to the power 4, and y is y to the power 4, and z is z square. That's why the required LCM 60 x4 y4 z square. Find the LCM of the two expressions. Now the first expressions, a square plus 7a minus 18. Now we apply the middle term method. Then we can write a square plus 9a minus 2a minus 18. Here a common. Then we can write a plus 9. Here minus 2 common. Then we can write a plus minus and minus. Minus into minus equal to plus. That's why you can write a plus 9. Here a plus 9 and a plus 9 are common. Then we can write a minus 2. The second expression, a square plus 10a plus 9. Applying middle term method, then we can write a square plus 9a plus a plus 9. Here a common term. Then we can write a into a plus 9 plus 1 common, a plus 9. Here a plus 9, a plus 9 common. Then we can write a plus 1. Therefore, the LCM a minus 2, a plus 9, a plus 1. Find the LCM of the three expressions, x square minus 4, x square plus 4x plus 4, and x cubed minus 8. Solution. The first expressions, x square minus 4. Here we see x square minus 4. That means we can write x square minus 2 square. We compare this expression into a square minus b square. Then we can write a plus b into a minus b. Then we can write x plus 2 into x minus 2. Second expression, x square plus 4x plus 4. Here we observe that a square plus 2ab plus b square. Then we can write x plus 2 whole square. After this, we can write x plus 2 into x plus 2. Then third expressions, x cubed minus 8. Here we see x cubed minus 8 is equal to, we can write x cubed minus 2 cube. 2 cube means 8. Compare x cubed minus 2 cube is equal to a cube minus b cube. Then we can write a minus b into a square plus ab plus b square. That's why we can write x minus 2 into x square plus ab means 2 into x plus b square. That means 2 square is equal to 4. Then the required LCM. Here we can see x minus 2, x minus 2, x plus 2, x plus 2, x plus 2, x plus 2. That means we can write x plus 2 into x plus 2 and x square plus 2x plus 4. After this, calculating this, we can write x plus 2 into x plus 2. That means x plus 2 whole square into x minus 2 into x square plus 2x plus 4. Now, here we can see a minus b into a square plus ab plus b square. That's why we can write a cube minus b cube. X plus 2 whole square into x cube, b cube means 2 cube means 8. Now this is your homework, and remember one thing. This type of creative question will be set your exam. Here A. Find the HCF of these expressions. This is easy level question. Then find the HCF of the given expressions. This is medium level questions. Then determine the LCM of the given expressions. This is hard level questions. That's all for today. If you have any query, you can ask that in the comment section. Lastly, I would like to remind you the most important thing. In this critical situation, you must stay home and keep yourself safe. Stay fine. Thank you.